Hey everyone, welcome to ECS number 5. So we're going to continue our talk on the entity component system. Now, one of my followers here, one of my subscribers, Janik, posted a thing about the compile time ID, which is right here. So I've dug into this and done a little bit of research on this, and I think it's kind of an MSVC thing. That's sort of what I'm seeing. Like, this might actually work on GCC, but this is not going to work across multiple translation units. I have a very simple little program that shows this. I've created this test class, which literally just has this const expression thing. I've created a test2 class, which is basically a copy and paste, and then they have a show that just says, ID and then ID2. I'll actually change this to 1 so that it looks good. Because I need them to be included in multiple translation units, I also created the show test, which literally just in the CPP includes both of these files. Sorry, let me zoom in. Includes both of these files and then just calls the show function on these guys. So that's it. It's just two classes that have this test going on. And then in main, I just spin it up and do it. So if I build this, what we would hope and what we would expect is that we would get 1 and then 2, and of course we get 1 and 1 in both cases. So the counter effectively resets across different translation units, and I am, my speculation as to this, I'm not actually sure. I don't know the answer to this, but my speculation is that I've read somewhere in one of my various deep sort of posts somewhere on Reddit or one of the Google forums or something that MSVC will do compilation across multiple threads sometimes, and so this could happen. It makes me wonder if I created 1,000 of these classes, if I would just get one across the board, or if I get more of your kind of standard multi-threaded thing where they'd be all kind of disparate. Every time I run this, it's different, or it's the same, I mean. If I run it in release, I'm going to guess it's probably the same as well. Yep. So, I haven't actually tried 32-bit mode, but I don't see why this would be any different. So, this is not going to work for us. So now what? We have to come up with some other method. So there's several, and I'm just gonna quickly kind of blast them out here. I guess I can just throw them in here. So option number 1 is we create an enum. So enum class, component type or whatever, or we could even say component ID. Maybe it's make an unsigned int. And then we have k transform, k renderable. And so now we have these auto incrementing things. And then in here, we basically just, set this to whatever. And we can still do a static const expression, all this other stuff. It's still a compile time ID. But we're manually creating this. So this is number 1. Now, this is not going to work. We can't use this method because this is going to live in the engine. So there's no way that we can inherit from this, which would be kind of nice. We can't say gameplay component ID or whatever. We can't do this sort of thing, right? So this just isn't going to work because we need to be able to define components in the engine and then add to them for the game side itself. Number 2. So the second method of doing this is, it's basically the same method. I'm going to say component ID type. So we basically say, we create some alias here that's component ID. I'm going to make it an unsigned int, and then we say component ID type. And then we do the same thing here where we have renderable whatever, and then at the bottom we say, gameplay component type or something like this. And then we have in the gameplay side, we say gameplay component ID type. And then we do, crew component equals this guy. And then now we can just say, AI target or whatever. We can just keep going. And so now we still have these IDs. And then, this guy, we just set them, right? We set it manually. So this is number 2, which is doable. I'm not super happy with it, but it's doable, right? Okay, so number 3 is going to be using GUIDs. So you can go, like, manually generated ones. You can go to Tools, Create GUID, and you just copy it, and there it is. And so then you would say here in, class, whatever, concrete component, whatever this is, right? Here you would have static, const expression, unsigned int, ID equals, and you would literally just do this. So you just manually have this sort of thing. Still compile time. Now, a couple of nice things about this. Number 1, this is self-contained. I'm not dependent on some external file that I have to keep maintaining. So it's here. It's also consistent. It's also generally better for hash tables, but that's not necessarily true. It's just a more sort of random value, which, depending on the hash table implementation, can be wonky. The hashing function implementation, I should say, but that's probably not really worth considering. Mostly it's self-contained, and that's what I like about it. Number 4, which is an interesting one, which is sort of a hybrid of the original auto counter and this, is we can generate this ID, so we don't have to use this tool every time. So it's kind of the same thing, right? We say concrete component, and I'll just put 2 here. Where we say static const expression unsigned int ID equals, and then we do something like we create a hash. We just hash the, I would actually just hash the name of the class, right? And there's different methods of this. Like, here's one that's nice and sort of generic. Like, we could hash the name of the file. The problem with this is that, 1, it's no longer consistent. So on different machines, I might have different paths, The people who work for me will sometimes, they don't necessarily have the exact same path that I do. So it'll hash to something different. Number 2, it's it's not, you can't have, number 2 is you can't have, you can't do what I'm doing here, where you have 2 components in the same file. And maybe that's fine. And that's actually probably reasonable. But I could see that you have, lightweight components. You have like 3 lightweight components that are all very similar to each other or something. And you just throw them all in the same file. Like, that's not uncommon. So now you can't do that. Now you have to do some, join of strings or something. Whereas, this method, the second method, allows me to, like, it's based on class. It's also sort of faster, for better or for worse. Like, file it could be a long path, whereas this isn't. Now, hash string, it's worth noting, you can do in compile time. Here in where, I think it's hashed string. Nope, that's not it. Where did I put it? Oh, string hash. Here it is. Yeah, so this is a compile time string hash implementation right here. It can run at compile time, but it will run at runtime if it has to. Just based on this hash helper, like which one it expands. Here at the top of this, you'll see this comment here. This whole technique was described here in Game Engine Gems 3 by Stefan Renalter. It's his particular article that I pulled this off of, compile time string hashing. I recommend it to understand exactly what's happening here. I even have the page number. The code here is a direct implementation of the techniques in that book. So I recommend checking that out if you're interested in how that all works. Check it out. I'm not going to go into the extreme details of what's going on here. If I go here, though, where is it? Here. I've created this little declare ID where I pass in the class. You can pass in anything you want, obviously. Where I do this. I don't know that this is better than what I had before, but it was sort of an instinct that I had to sort of generate this with this thing. But you can see here I have test and test 2. If I build this guy and sort of run my same tests that you saw before, here they are, you know. They're nice and consistent, and you know, they would be here. Across any machine, it's going to be the same hash value. You can calculate this hash value at runtime if you want to. You can calculate it at compile time. You can do kind of whatever you want. So, you know, you could easily create some kind of factory that makes this all work. So anyway, you know, this is kind of how it works. So as long as the class is named the same thing, it's going to have the same ID, or as long as whatever you pass in here is the same thing. So those are kind of our 4 methods. You know, I don't know. So I don't think number one is right out, right? We're just going to get rid of this. That's not going to work. Number 2 is reasonable. You know, if we enumerate some of the advantages of number 2, you know, one advantage is it's fast, right? A disadvantage is there's some coupling, like there's an additional, I'm going to say, it's not a good word to put it. There's some there's admin that you have to do, right? Like that's kind of annoying to have to like keep these things in sync and all that kind of stuff. For number 3, there's still admin because you still have to do this sort of thing. And it's also very fast. Like these are very similar, but they're sort of like, I'm gonna actually say manual. Like this is a manual way of doing it. Here, number 4, this is sort of mostly automatic. Another nice thing is it can be calculated at runtime, right? You can, for example, inside of a script, you could, like inside of Lua or something, you could say, okay, let me calculate the hash for this thing and then do a lookup based on that. And just send in the hash or whatever, or it could even send in a string, and then on C++ you could do the hash and say, okay, this is the component that they're asking about. So you can grab C++ components without having to like expose this specific ID up here. Like you can just do it. However, it's slow. And when I say slow, all of these are super fast at runtime, but it's slow compile time. If you have if you have hundreds of components, or you know, even perhaps dozens of components across, you know, a million lines of code, and you're constantly including all these things, you know, if you look at the string hashing function or how it works, this literally, you know, runtime, it just calls the fnv1a hash function, right? It just calls that guy. Here it does something a little sort of crazier. So it does sterlen -1, and then it calls this generate, which is going to be this guy up here. This generate is going to basically recursively for each element in the string, you know, do this sort of like XOR multiplication sort of wonkiness to generate the appropriate hash for that particular thing, which is why all this prime stuff is here. And then again, finally, like once it reaches 0, then of course this guy takes over. So you're expanding, you know, this template recursively. So, you know, size, length of the string is going to determine that a lot. Going back to this, that's also why I think this is maybe not the right way to go, because this is just going to be a much longer string than this. So I think whatever we do this. So I don't know. You know, maybe file is fine. My own engine compiles pretty quickly. It's something like less than a minute. It's maybe 30 to 45 seconds on this machine, and close to a minute on my laptop, I guess. And that's a full rebuild. I clean and build everything. And there are a lot of files that I don't have to build that much. But anytime you're including templates in a large series of things, it's non-trivial. So you're going to add your compile times. Very much. You're going to add to compile times. So you have to keep that in mind. That's why I say it's slow. Okay, so that's it. I think I've talked about IDs for long enough. I think we can start making some modifications and start moving on to the next thing. But these are the types of things we have to consider, right? Like, how are we actually going to generate this stuff? In my current system, my non-ECS system, in my own engine, I actually do method number 3. This is exactly how stuff works. I don't think I have it actually open. This is exactly how I generate things. It's just a manual sort of thing. Let's look. Space Sim. So I'll open this up and I'll kind of show you what I'm doing. And it works fine. It's sort of a pain in the ass a little bit. If I go to... Come on, buddy. Oh, there we go. I don't know, transform or something. I have a lot of Visual Studios open. There we go. Transform, component, interface ID. Yeah, so here's all the interface IDs for every engine level component. The gameplay has something similar. It just defines them, and it's literally just, I just used that same tool that I showed you. This is literally what I do. And so here it is right here. And that's, it's worked reasonable. It's every time I add a component, it's a slight pain in the ass. But again, fast, easy. Once it's done, it's done. It's consistent everywhere because it's literally just this thing. So, I'm not actually sure which of these I want to do. So I'm going to do the hashed string because I've not done it before. That's just not a method I've done, so it'll be interesting to see, to try it, see what happens, see how it works. It's not hard to kind of do this. Like, it's not actually that hard. It's also worth noting that this is not const expression, which is interesting. And that's probably the more intelligent thing to have done, is to make some kind of const expression thing here. Although this should still be done at compile time. There should be no issues there. And this system was created long before C++ 11 was even a glimmer in anyone's eye. So, I'm going to do the hash string method because it's different and it's kind of fun. I think that's what I want to do. So that's the plan. But number 3 is also pretty valid, and really the enum is mostly valid. It's just, I don't like having an additional thing. If I was indexing them in like some array, that would make more sense, but I don't like doing that. Okay. So that means that we have to modify all this stuff. So all this renderable crap goes away. All this goes away, and I have hash string, and I'm going to say, oops, come back to me. Renderable. So like this is kind of one way to do it. I think this just makes sense to do it this way, like this. Right. What am I missing? I'm missing you. So string hash. There we go. So there we go. Now we have this nice hashed string. Very nice. Now I want to go to... I'm going to test something briefly. It doesn't matter. Where's the other one? There we go. So now we need to change this guy. String hash. And then we do the same thing here. Hash string. Transform component, and then that's it. So now we have these nice, simplified kind of things here. So this all looks pretty good. And we can kind of do any of this stuff with any of these other sort of systems or anything that we want to do. This should all basically work. Okay. So perhaps while not super exciting, we have solved this particular problem, I think. And I think this is the direction that we're going to go. And I think components are basically solved is maybe a harsh word, but I think components are basically here. I don't see any real extra functionality we're going to add to them. And I want to very briefly go over what's already here. So our entity component looks like this. It has some hidden data and some ways of kind of getting to that data. This set and get entity ID is sort of weird. I do think we're probably going to end up making this private so that it can only be set in a very particular point, or possibly even trying to do something in here. Like, we need to consider how this is going to work. Same thing here, right? We need to consider how these guys are going to work. But I think this is reasonable in hiding this data and hiding all this stuff. I think it's the right thing to do. We don't have anything here in the CPP. We'll probably get rid of it. And if we look at the actual data itself, we're following the ECS, guidelines. If I go back to this, here it is. The sort of tenets that I said that we need to follow. Components have no functionality. Systems have no state. Entities are essentially IDs. So I want to see if we're sort of still following this. Yeah, those are all the major things. And we are. We don't want functionality. Here's the data. It's laid bare. Just operate on the texture. Like, all the functionality is going to be outside of this. Same thing for transform. If I'm going to modify this or tweak it, systems will tweak or modify or do whatever they want. And it's on you to do safe things. We're not going to have a bunch of functions modifying it. Some people disagree with this. My philosophy is, maybe we might do something, like get rotation degrees. Like, I could see this being a thing that we might do, right? And then this would be radians 2 degrees. M rotation radians. Like, this is just an example. This is maybe a bad example because I could just do this in the system trivially, but this might be an example of something where I'm going to create some kind of like getter or something like that. Really just a way to transform is maybe not the right word, but a way to get a different view at the data. Maybe. I'm not even sure that that's true, but I might make some of those concessions. Mostly, the only sort of pseudo functionality that we have is the virtual init function, and that's a hill I'll die on. Like, I definitely think we want to have this. I'm very much a two-stage initialization fanboy, so having an initialization function here, we instantiate the component and then we send it, the particular XML chunk, or in my own engine, in my case, I use Lua for data, so I send the appropriate Lua table. Internally, it then does whatever it needs to do to load that data. Usually, it's digging through the table internals and then setting internal variables. So this initialization is fine. I'm not going to have some system do that. That makes no sense. So also, obviously a virtual destructor, so that when this thing goes away, for this, where are you, render system, oh, not render system, renderable. As you can see, I'm already doing it here. I'm destroying the texture appropriately. So like, this functionality I think is perfectly valid, but that's where the line is going to be drawn. In terms of the kind of ECS tenant of, everything next to each other, all that kind of stuff, I just don't think in a realistic game engine that we're going to get that. Not perfectly. We'll get some semblance of it, maybe, but it's never going to be perfect, because what's going to happen is systems are going to ask for disparate components, and so like I can't group those components together, but I'm going to be accessing them in different ways, right? However, all renderables will generally be stored together, all transforms will be stored together, and so on. I can't change the access order in which that's going to happen. So, I don't know of a simple way to make that work, because you're always going to be jumping around. Like, that's gameplay. That's how games work. So you just have to live with that. They will, however, all be next to each other in memory because we're using a memory pool. So all texture and a specifically sized memory pool, all textures, or not textures, sorry, all renderables will be right next to each other. All transform components will be right next to each other. So if for some reason I am literally looping across all transform components, then there you go. And so, there's probably other ways that you can do sort of smart grouping and that kind of stuff. But for this system, I think this is a decent first pass. And it is optimizable because I'm not tied directly to how these things are organized. And honestly, I think you're going to get more optimization from, other things. But they will all be kind of next to each other. All like components will be next to each other in memory. And that's probably what you want. When we get into systems, which is the next video, we will kind of have to rewrite how some of that stuff works, and you'll see how we loop across, those types of things. If they happen to be next to each other, we'll gain the benefits. I think that there's a relatively decent chance that they won't be next to each other, and I don't think it's worth sitting there constantly sorting it. But we'll see. We'll see what happens as we dig into the systems side of things. So I'm going to stop it here. That's it. We're, probably 25 minutes in, because we're going to start another big topic, which are systems. And we've talked about them a little bit, but what we need to do now is we need to really dig into what is a component system. Right now we just have this sort of placeholder. The systems are going to be a whole other can of worms, and that's where I think the majority of the real complexity of the system is going to come in. Okay, so that'll be next week. I will see you then.